Iggy, can you say hi? So Miss Megan say hi. Brother, huh? Okay, come on. Nikki, I want you to sit on your bottom or on your knees. That's okay.
Here, Miss Megan wants to see you guys. Can you guys sit really close to each other?
Hi guys, how are you?
Talk to her. Tell her about your time away.
You can tell her about reading.
I'm reading.
You're reading?
And you want me to believe what I brought. I'm not going to tell you. No, not yet. Now, it's going to be like that. Yeah.
If you can hear me right now, can you guys go ahead and either send a comment in the chat or somebody unmute themselves and just let me know?
I can hear you, Miss Galandri.
Okay, thank you. I had my headphones on and they clearly weren't working, so I'm glad I figured that out before I started talking. Okay, we're gonna go ahead and get started here. Remote learning review session here because you guys asked for it, so we're gonna do that. Feel free to, a few different things, either put a question in the chat. I have that open on my phone off to the side of me, so I can look at those, even if it's just as simple as what like Mia put on Google Classroom, that it was 713 notes number 2. Whatever it is that you guys have questions about, please ask that, or feel free to do what Jackson just did there, just unmute yourself and ask a question at any point. Even feel free to interrupt me, any of that kind of stuff, and help us out if there's anything else that we can do. But this is kind of more for you guys. So I'm just gonna start with Mia's question and see what I can go from there. And Mia, if you have anything to add to it when I get to it, feel free to ask away. So let's see if I can get all of this going. I'm going to go to 713. And I have all the notes just so it'll be simple for you guys. She was asking about 713 number 2. So I'm going to go down to this one here. Okay, there we go. Let me make it a little bigger for those of you on phones. There we go. Okay, so if we go through this one, in figure 2, event B, sorry, give me a second. Oh, lost my pen. There it is, okay. Okay, I have control. So in figure 2, event B, the rectangular region to the right, outlined in pink, and you can see mine's actually colored, your guys's is not, has been added to the area probability model for figure 1. Find the following probabilities. So the probability of B. So we have this rectangle B that's right here, and to find the probability of it, like it says at the top of your page, or middle of your page, you're going to do the probability of B is the area representing B. So this is a 1, 2, 3, 4, 5 by 1, 2, 3, 4 box. So 5 times 4 is 20. So that's going to be the number on top. Okay, this is a probability. This isn't the number of outcomes in B, okay, which is number 20 there. And then the area of the region representing S. So S is my big figure here that we figured out earlier, but it is a 16 by 10 box, which is 160. So to find your probability of B, you're going to do 20 divided by 160. You can report that as 1/8. Again, with any of these probabilities that you guys are dealing with, you can give it as a decimal, as a fraction, or as a percent. So it's up to you. I'm just not going to change that because that's the first one that I got through there. So that would be 1/8. Okay, so the probability of A intersect B. So intersection of A and B is going to be these 6 boxes in here. Okay, so to find that, I'm just simply going to say the top is 6. The intersection of A and B is 6. And then the whole thing is 160. Okay, I'm going to do 6 out of 160. So the probability that it lands in this little area here, 6 out of 160. That one is going to simplify to 3 out of 80. Again, you can leave it as a simplified fraction. You can write it as a decimal or a percent. And a lot of you will change it to a decimal or percent, so that's just fine. Okay. Letter C then suggests that Jason decides that he can calculate the probability of A union B. So that would be all of the blue area and all of the pink area put together by just adding the probability of A and the probability of B. Is Jason right? So the answer is no. Okay. If we do the probability of A union B as the probability of A plus the probability of B, okay, our probability of A will come from what we have of this grid, which in question number 1, you figured out that this has 40 blocks in it, okay? So it would be 40 out of 160. Plus, here we just found out that this was 20 out of 160, okay? And we would solve that, you'd get 60 out of 160. The problem is there are not 60 blocks in A and B. And the way that we got 60 was that we added these 6 blocks twice because they are in both A and they are in B, and so we added them twice. So what we have to do is we have to then subtract the probability of A intersect B. Essentially what this problem is getting at is if you look at the top of your page, the general addition rule is why that's the case, okay? So your answer here is no, okay? And something about the fact that he must subtract. So you guys get to hear my kids. The probability of A intersect B. Iggy, you need to go out of the room. Hey, Grandma, can you come get Iggy? So you have to subtract the probability of A intersect B. Otherwise, it's counted twice. Okay, so hopefully that answers your question, Mia, but keep asking questions. This is really going to be powered by you guys. So feel free to just unmute yourself and ask a question. Feel free to send it in the chat and I can skip to whatever I need to.
For letter B in 7.2.4 on the worksheet, how can you just walk me through how to do the fundamental counting principle?
Yep. Okay, wait. 724, you said letter B on the worksheet. What number are you on?
Oh, 3. Sorry.
That's okay. These are nice and confusing, but at least they let us talk through that. Okay, so 724, number 3B. Okay, yes, let's just go through all of 3. We've got time
Okay.
here. Okay, here we go. Okay, so number 3, we're talking about the Connecticut lottery. And sorry, I picked Connecticut instead of Illinois, but that's okay. The Mega Millions game, you begin by choosing 5 different white numbers from 1 to 75. The order does not matter. So this is the first thing that we really need to pay attention to, is that it does not matter. So we're talking about combinations here, okay? And we're the numbers 1 through 75. Then you choose one mega ball yellow number from 1 to 15, okay? So we're gonna choose, I'll use gray, but we're going to choose 1, 2, 3, 4, 5 white numbers, and then you're going to use, find a yellow one as you go through this, okay? So that's kind of the idea. The order doesn't matter. So the fact that I did this one first, second, third, fourth does not matter. It could be, if this was number 1, the number 1 could apply in either of the places. So how many possible ways are there to choose the 5 white numbers, not including the mega ball? Is this an example of combination or permutation? So right away, I'm going to say it is combination. Okay, it's combination because the order does not matter. So I'm going to do a combination here. And what I'm doing is I'm choosing 5 different balls from the set of 75. So I have 75 I'm choosing from, and I am choosing 5 of them. Okay, now your calculator, and give my calculator a little bit to get up here and I'll put it out, but your calculator will be able to do this for you. Okay, so 75C5. And if you type that into your calculator, and if we give this a second, I will share my calculator with you guys too. I'll get back to that when I get there. So if we get back to that calculator, but if you type that in, you're going to get 17,259,390. Now, just to clarify for combinations and permutations, at the end of the 723 lesson, in the beginning of this lesson, I had you practice the formulas. Don't worry about those too much, okay? For what we're doing here, you're going to be using the calculator to do this, okay? So don't hesitate on just using the calculator and not necessarily understanding how to do those as you go through there. So we have that 17,259,390. So letter B then says, how many possible ways are there to play the Mega Millions game? In other words, how many ways to choose the 5 white numbers and the yellow one? Okay, so now we're at that and question. And this is where it always gets interesting as to how to do this. So what we are really doing here is we're making 2 random choices, okay? We are choosing out of the 75 balls, 5 of them, okay? And then we are making a second choice. So here's my fundamental counting principles. I have one choice and I have another choice. How many ways are there to choose 5 white numbers? Well, there's 17 million of them, okay? And how many ways are there to choose 1 yellow number? So this one is, I have 15 yellow numbers and I am choosing 1 of them. And so what this is doing is it's telling you how many different ways are there to do that and how many different ways are there to do this, and we can multiply those together using the fundamental counting principle, okay? And so that's going to give you, if you solve that out, 258,890,850. And now I have my calculator up, so I'm going to go ahead and just show you guys how to do that in case anybody has a question on that. If I'm doing this right. And share. There we go. Yep. Okay. So there's my calculator. Ooh, it looks kind of funny. Well, maybe it is, maybe it isn't. There we go. Okay, so if you were trying to type this in, again, you're going to go to, you have to be in a calculator screen. Okay, so you have to get into a calculator screen, and then you're going to go to menu. You're going to go down to probability, and you're going to pick whichever one you want. So I want a combination. Now, once you do this, you're going to see NCR and then parentheses. In these parentheses, if I'm trying to type in 75C5, I type in 75, comma, 5, and then I hit enter. And that's giving me that first number that I had, okay? And then I want to multiply that, so I'm just going to hit times by 15C1. And you could do both of these at the same time, but you can go back into your probability, choose a, maybe, there you go, choose a combination, and then I'm going to do 15, comma, 1, and I'm going to hit enter, and that's going to give me that amount. Okay, so that's how I got this last number here. Okay, let me get rid of the calculator. Okay, here we go. I think I figured it out. Okay, so that's kind of how that one goes. So this one is a tricky problem, but it's mainly the idea of, okay, how does fundamental counting principle and combination permutation come together? So there's 2 things you're doing. You're choosing 5 balls and you're choosing 1. And how many ways are there to do the first and how many ways are there to do the second? Okay, just to keep going here, because I think it's helpful just to see these. So what's the probability of winning the Mega Millions jackpot? To win, you must match all 5 of the white balls and the mega ball yellow number. So there is only one way to win that jackpot. Okay, you have to have all 5 of these correct and this one correct out of that 258,890,850. Okay, and so then you can give your decimal there, but whatever you want to give, it's going to be a lot of zeros, and you can keep going out of there. 386. Okay, so this is the one that a lot of people get wrong, is letter D. The prize for matching all 5 of the white numbers but not the mega ball is $1 million. So what's the probability of winning $1 million? Okay, so what we can look at here is the fact that there are 14 ways to match all 5 white numbers but not the mega ball yellow number. So here's what we want to think about. There's all these ways to get white numbers, okay, but we're talking about only the 5 that are correct. So we're saying we got these 5 correct, but we don't want to get this one correct. So how many are there over here that make this one not correct? And that's 14. So there's one way to get these 5 correct, and there's 14 ways to get this one incorrect. So 1 times 14 is 14. That's where this number comes from, okay? So it's 14 out of that 258 million. And then that's going to come out to a pretty big decimal there, okay? And then that kind of gives you an idea of how that works. They report it as 1 in 18,492,204, which is essentially just the fraction. So that's how they report them, as the fractions there. Okay, so that is that question. Let me know if anybody has more questions about that. It looks like Mia has a question on 213, so I'm going to go back to 213. Oh, there it is. Okay, 213, number 5. Won't zoom in too much here. Okay. And just bear with me as I flip through papers here back and forth. Okay, there we are. Okay, so find the following probabilities related to the events in the probability area model. So again, we're doing this based on this area probability model, which is still 16 by 10. And apologize for my, there's technical difficulties here. Okay, we'll just pretend 10 was written there. So it's still 160 square units in that box. Oh, come on. Okay, so find the probabilities of each of these. So it's dealing with your area formulas with these different formulas here, or these different shapes here. So C is a rectangle, okay? So you're finding the area of that rectangle. This rectangle is 4 by 7. And so that's got 28 units in it. And then your triangle, this A triangle, and some of you may have had questions. I don't know if this is where Mia's question came from, is because the colors are kind of hard to follow, but that's where your A ends and that's where your B ends. So your A is tall, 1, 2, 3, 4, 5, 6 tall. And it is 1, 2, 3, 4, 5, 6 long. B is the same way as 6 long on the bottom, but only 4 tall here. Okay, so we have a few different things that are coming up there. So the area of C ends up being 28 out of the 160. Again, you can simplify fractions, and if we have questions about that, you can go from there. Using only your answer to A for the probability of C complement. So all that means is do 1 minus what we got in A. Okay, understanding the complement rule is that the probability of C is going to be 1 minus, or probability of C complement is going to be 1 minus the probability of C. Okay, so solving that out and getting your answer from that. The probability of A, so it's a triangle. Okay, so to find A's area, we're doing 1/2 times the base times the height, which is going to be 1/2 times 6 times 6. Okay, so half of 6 is 3, 3 times 6 is 18. So this one's going to be 18 out of 160. Okay, because all of these are out of that whole region that's there. And solving that one out. B, same thing, I'm going to do 1/2 times base times height. So half of 6 is 3, 3 times 4 is 12. So this one's going to be 12 out of 160. And you could solve that one out. And then the probability of A intersect B. So this is this triangle in here. Now, some people are like, okay, I can count little pieces, whatever, but think about triangles in area. It's all based on height or base times height. So the base here we can actually count is 1, 2, 3, 4, 5 boxes. And the height here is from a vertex perpendicular to the base. And that happens to be 2 boxes. So I can do, for this area formula here, I can do 1/2 times base times height. Half of 2 is 1 times 5 is 5. And the overlap of A and B is 5 out of the 160 that's there. So that tends to be a little bit of a tricky problem there. But you can simplify and you can go from there. Then the last one, using only your answers to C, D, and E, find the probability of A union B. So this is working on your formula, and that's the fact that the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. Okay, so we found the probability of A. That should have simplified. Well, actually, I don't want to simplify here because I want to be able to subtract fractions. So 18 out of 160 plus the probability of B, 12 out of 160, minus the probability of the intersection, which is 5 out of 160. And so I can essentially do 18 plus 12 minus 5. I can get 25 out of 160 and then simplify that. Okay, so that's 2.3, number 5. Again, you guys, it doesn't look like I have any other questions at this point, so feel free to join on the microphone or send a message in the comments. So while I'm waiting for potentially some more questions, feel free to interrupt me. I'm just trying to give you guys some information here. We've been given new information. You guys are going to be getting it about end dates for school and stuff like that, and new information. And so we're not going to be able to do the reviews only on Fridays. I'm more than happy to still enter in a review, but to get through everything, I revamped the schedule and kind of have it the way that it's going to go. But the nice thing about that is that you're going to get essentially a week and a half to just catch up on anything, ask questions, anything like that that you need to. So and I am willing to take any assignments all the way through the end of the semester. So if you're behind on something, that's fine. Feel free to get caught up at a different time. Okay, I have 724, number 1A through D. So let's go ahead and go to that. 724. Number 1A through D. Okay. Okay, so we're arranging students in a line at the front of the room. If we're looking how this one goes through, there are 20 students in a line at the front of the room for a class picture, and you are interested in counting the number of possible pictures she could take based upon the number of arrangements of students. So this is about arrangements. Okay? Does the order of the students matter when counting the possible number of pictures? Because it talks about the arrangements of students, the answer is yes. Okay. It talks, and again, it's just really based on that idea that it says arrangements of students. Okay. So we've got this, and really what this comes down to is if any of you guys think about like getting in a picture, like, do you care who you stand next to? Some of you are like, absolutely not, but do some people? Yes. And so that's where this is an arrangement question. So if we know that this, in this case, that the order does matter, okay, then we're talking permutation. So that's the other thing that this should right away kind of clue into you is we're talking permutations, okay? If your teacher chooses a student to stand in the first position in the line, does that have an effect on how many students she can choose from the second position? And the answer again is yes. So imagine this, we've got all of these different places and they just keep on going. If we choose person A to stand here, okay, can person A stand here? And the answer is no, okay? There's only 19 students left for this position, okay? And then so on and so forth from there. So how many different arrangements for the picture are there? Well, this is a permutation, okay? How many are you choosing from? So as soon as you figure out this is a permutation, it actually makes the problem easier, okay? You are choosing, there are 20 students that you are trying to choose from, and you are choosing all 20 of them. So this is the tricky part of this one, okay? You have 20 students that are in the class, okay? How many of them do you want in the picture? You want all 20 students in the picture, okay? Now, if this was a combination, it's a totally different answer than if it's a permutation. But this happens to be a permutation here. And so if you type this in, you get a really, really, really large number, and I'm not going to try to read it because I'm going to read it incorrectly. And this is why we have a calculator to do all of this for us. So you get this number of possible arrangements, okay? If this was a combination, the answer to this question would be 1. So you can see the total difference if it's 20P20 versus if it's 20C20. So this is a permutation, we care about the order, and there's a lot of possible arrangements, okay? Sharon is hoping that she will be first in line. If the teacher randomly chooses the order in which she arranges the students in line, what's the probability that Sharon will be the first in line? So what this comes down to is you're like, okay, does anything else matter? And the answer here is no. You could care less who's anywhere else in the line. All you care about is that very first position that this is Sharon. Okay, and she wants to be here. What's the chance that she has to be here? Well, there's 20 students to choose from, and she's one of them. So it is simply a 1 in 20 chance. Okay, she's 1. There's all the students, and so that comes out to a 5% chance that she's going to be chosen first. Okay, so don't make that one too complicated. That's as simple as that is. Again, this one tends to be the tricky one there, but use your calculator. Don't feel like you have to go through the permutation rules. I think it's important to get a general understanding of them, but you're going to use your calculator on stuff like that. Okay, again, feel free to jump in on the microphone or jump in the chat. I'm looking at both. I don't want to skip your questions. If you're typing something, keep going. I'll talk for a little bit to give you a chance to type a little bit more, or we can be done if that's all the questions. Oh, we got another one. Here we go. Thank you, Victoria. 724, number 3. Okay, 724, number 3. Oh, we did go over that, Victoria. So I'm going to post this video on Google Classroom, so you'll be able to go back and look at that. It was one of the first ones that we went over there. If any of you guys have questions as you work through these problems, feel free to send me an email or send a message on Google Classroom, anything like that. And I can do a quick video just like this and just send it out to the whole group to give clarification on stuff. So don't feel like you have to wait for a review session if you have a question on a specific one. Just send me which one's the question and I can do a quick video and send it out, and then we don't have to wait for review sessions, just so you guys know. Looking toward the end of the semester, again, I'm waiting for questions, so feel free to interrupt me if you want to voice in a question or send me a chat message. But looking toward the end of the semester, you guys will have a test at the end of the semester, but I do plan on it being open notes, open calculator, all of that kind of stuff. Just really testing, did you get how to do this? Were you working through your notes and homework from there? So as long as you're doing all of this stuff, you're getting a general understanding, I think you'll be good on that. I also posted the Khan Academies that are essentially scheduled for Tuesday today. So if you want to get a head start on those, you can, and keep working for those 100%. Okay, I'll wait here for about another 5 minutes, but if nobody has any questions, then we'll end this. So feel free to take off if you want to. If you have another question, send in a chat or come on the microphone.
For number 7 in the 7.2.3 notes.
Yep.
Sorry, what?
Go ahead, you're good.
I was a little confused on just how you got those numbers, I guess. I'm not sure.
Yep, we'll go over it. Like number 7, the one that you can see there at the bottom.
Yeah.
Okay. Okay, so this was our jelly bean question. We have, I lost my board. Here we go. Okay. So we're generalizing our results in question 5, assuming you start with n different colored jelly beans. Okay, how many ways can you randomly select k jelly beans and arrange them in a row? So what we figured out from these questions above, I'm going to use these to kind of help me here, is we figured out that this one was 6 times 5 times 4 times 3 times 2 times 1, and so on from there to get each of these answers. And so what were we doing? Okay, well, what we're talking about down below, okay, is that n is the number of jelly beans we have to choose from. So here we had 6 jelly beans to choose from, okay? And then k is the number of jelly beans you're choosing. So like in this one, this is my k. Okay, so we're using those 2 concepts as we go. So try to generalize your results. So what did I do? The first number was essentially your n number. Okay, so as I went through, and I don't know how many lines that I need, but as I go through, this first number is however many jelly beans I have total, okay? And then it's 1 less than that. So how do you write that? Is you write as n minus 1. And then it's 1 less than that. So n minus 1 can be written as n minus 2. And you can keep going from there. You can go to n minus 3. You can keep going. Okay, so this is the beginning of it. Now, the problem is that we don't know what number k is. And so the way in math that we write that is we say dot, dot, dot. And so you can go as many as you need to, or you possibly could have skipped one of these if it was only 3 numbers or something. And you write it as n minus k plus 1. Now, where does this come from? Okay, this is usually the hardest part here. If I come back up to this example here and say, how would I say that I wanted to stop at that number 3? Okay, well, n in this case was 6, k in this case was 4, okay? And how do I get to the number 3? Well, I do the 6 minus 4, but it's not quite that, it's plus 1. Okay, so this is n minus k plus 1. And you just look at the pattern. How did I get to this 2? Well, the n in this case was 6, the k in this case was 5. How did I get to 2? I did 6 minus 5 plus 1. And it just keeps going through that pattern. And that's how you're able to get that n minus k plus 1 that is down here. And that's what makes the problem. Now, these dot, dot, dots, just to be clear about that, are multiplication signs. So they're in the middle here. They're not at the bottom. This is essentially all these are multiplied by each other. Okay, so that's where that pattern comes from. Mia, feel free to jump in, or anybody else if you have more questions.
Well, is there any certain reason why you used the question C for that one with the 6?
No. So let's just use a different one just to give you an example. So let's say I used E. I guess, are you saying, like, is there a reason I'm using jelly beans versus something else?
No, I was just because I see like the C, the K would be 4, but it would be different in a different question, correct?
Correct. So the N and the K could change, and it will change. Like if I come down to E, in this case, my N is still 6. My K in this case is 2 because I'm choosing 2 of them. Okay. And so then 6 minus 2 plus 1 is what we would have for our final answer. So 4 plus 1 is 5. And what you should have, if you look up here, is that you should have had 6 times 5. Does that help a little bit?
Yeah.
Okay. And so understand that, like, this one only has 2 entries into it. And if we come back down to what I have here, you would look at this and you would be like, well, shoot, you got to 6 times 5 times, you don't have anything in each of these. The way that in mathematics this kind of a statement works is if you get to this value before getting through all of these, you stop. So what this is saying is start at n, go through the number that's n minus k plus 1, and do all of the numbers in between.
So it could possibly go all the way through n minus 6 since there's 6 jelly beans?
In that case, yeah, you could go up to the very top example. That's the 6 times 5 times 4 times 3 times 2 times 1. And you're choosing 6 of them. And so think about that. That n is 6. You're choosing 6, so that's your k. 6 minus 6 is 0, plus 1 is 1. And so if you look up at 5a, your last number was the 1.
Okay. That makes more sense.
Okay, yeah, and it gets a little confusing. This is not a perfect idea. Really what I want you to take out of something like this is, how can I generalize, like, how do I get the next number? And I think most of you from looking at question 5 will figure out that, okay, it's the first number is how many do I have? And then how many times am I choosing it is how I figure out my next numbers. So what's left over is I subtract 1 each time. Any other questions? Do any of you that are in here have questions about how online learning is going? Anything else, just school-wise? Anything I can help with possibly? Okay, I'm gonna go ahead and end this. Again, like I said, please don't hesitate to just send me a question. I'll make a video because I know this kind of helps, and then you can kind of go back and forth. Send me an email and just say, hey, can you do a video of this question? I think it'll just help me so I can explain stuff, or I can jump on a chat session like Mia was just chatting with me. If you want me to jump on a chat session with you, just, you know, hey, can we do a chat session anytime between 2 and 4 works? And I can send you an email with a link. So let me know. Hopefully you guys are doing okay and still learning a little bit, but also don't stress too much. You're going to get open notes for any of this. So let me know if I can help you with something. Have a great day, guys.